Hello everyone, it's June the 1st. All right. Today I read some code like as usual and probably see the most hairy things ever in in code. It was just so much to deal with. But hold on, I'll come back to it. I need to handle my cat first. All right, the cat is out. Yeah, it was just never-ending branching of the code. You enter one function, and inside there are like two functions, and then you go to one function, there are like three functions. And I talked about this a few days ago, maybe yesterday. But the thing is, these functions have data passing through them, and there's no documentation on how the data look like. And because of that, you are completely in the blind. I mean, you might have a mental image of how the data looks like at the beginning, but after 3 rounds, several branches, you have no clue, right? No clue how the data look like, even if you still do. All these functions are contained, they're methods of a class, and the class creates some, you know, variables inside, right? And those variables are some forms of data from other sources. And then when you have a function got passed a data that you don't know the shape or you don't remember the shape, and it uses something defined elsewhere in the class to do some data validation or do some um, just formatting, and I just completely lose my head. It's just impossible. There are too many things. I can't store all of them in my head. And you're jiggling too many balls. So yeah, I kind of just gave up at the end. I can't handle it. I can't handle it no more. So didn't finish that. So tomorrow we're gonna do the we're gonna do the unthinkable, which is I'm gonna use the print function very liberally. I'm gonna print almost each time I see something that I just can't remember, some data. I'm gonna print it out, and then I'm gonna do very good documentation on my own, right? On my own notes. I'm gonna write down on this function what this thing look like, what that thing look like. Otherwise, it's just impossible, at least for me, impossible to even understand and comprehend this whole thing. Not that I said this, maybe the better thing to do is to improve the documentation. It helps me and helps future people who need to look into this. That might not be a bad idea. But the thing is, like, um, some of those classes are shared by many different modules, and then they all come to this class to, modify the data shape, validate, consolidate, and the result might not be exactly the same. I don't know. We'll see. We'll see. Maybe tomorrow we'll find some pattern that we can put in the document in the doc string, right? Or put something in a doc string, and that will be helpful to me, to other people look into the code. Otherwise, this is just so mind-boggling. All right. Anyway, so that's a little bit complaint. So today, this is a challenge, which is transpose. Oh, transpose, right? Transpose. So, which I think we probably can do, we can say import numpy as numpy. I haven't used numpy for a while. So np dot array matrix dot t dot to list. Is that what it is? No to list. How about this? I don't remember. Do you mean to list in this one? Oh, yeah, that's the one. Are you kidding me? I'm using numpy and you give me 5%. Alright, so we're gonna do, of course, we're not gonna use numpy because that's borderline cheating. So basically, this is the first column. So column become rows, right? So we're doing diagonal swapping. I'm just thinking if there's a better way just to draw this out. Right, and then is it a... Now, M and N can be different. They can be... Oh! They can be different. It's not that trivial. But basically, the first comment, we can... No, swapping is not going to work if it's a rectangle, right? So a better shot is just to create a new one and then we just iterate. Oh, yeah, let's just do it that way. That overall is a better way to handle this. So we're gonna create a new one. The hell is this? We're done with this. Oh, shoot. We're not done with it. Ha! I remember yesterday I said I'm gonna have to read the solution. Yep, we're gonna do that, but we're gonna do this first. So what do? We have the grid equal to same old. Forget about this. Alright, and then we say grid is the result. So we're gonna have, let's call it 0 times m for this in range n, right? So what do? We're gonna go column by column. So for j in range n, right? And for I in range m, we're going to say matrix of what? Ij, right? Matrix Ij, not matrix Ij, grid Ji equals matrix Ij, and then return grid. What are you doing, man? Okay, so this, I'm sure you run both test cases. Yep. think it's going to be faster. It is faster. Did they do this intentionally to get NumPy so slow? I don't know. No clue. I'm happy that we got this one. All right. Let's see what's said in the solution. Copy. I think that's the one I will use. Oh my, this is a good solution. Oh, the zip. Oh, a zip. Yes, zip can work. Zip deconstruct the matrix. So we got a row out, right? So basically you zip a row, and then we put them together. It will be everything, and we just need to, for column, right, in this, and we put into a list, and then we return this thing. That shall work as well. Didn't think of this. And of course, for I in range, line matrix. Well, actually, we go J first. Matrix. No, this is matrix 0. Right, and then we say A. IJ. Right, because J is the first level, I is, so we go I first. So I think this one will work as well. This is basically the same as my solution, but written in one line. Why do you say A? There ain't no A, man. Nope. That was wrong. J on the outside, I on the inside. Yep. I shall score similarly at this one. Interesting. Very interesting. Wildly different. Wildly different. Alright, anyway, so we're done with this. So we're now going to solve this, but try to look at this one. So this is yesterday's problem, the fire thing. We got the idea correct, right? We got the idea right, but our implementation is quite convoluted. Let me actually bring that up again. Which one? This one, I think. Yeah. Max minutes. So our implementation is kind of wild all over the place, and he has a good implementation, so I want to check it out. Yes. Some tricks. I did this one too. Okay. Yep. Oh, okay. It's not 1 more second. I think it's 1 more minute. There's rebuild the A, rebuild, okay, the fire. Here's the time. And t plus 1 smaller than this. Because this is the current time. I visited ahead of time. This is the next time point. If the next time point is smaller than this, then we can visit it. And if we can visit it, we append in the queue. Oh, he uses the lazy one to build a queue. And then what? Come back up. If it's smaller, yeah, if it's smaller, it means we hit something we cannot do. The wall. This is the wall. Otherwise, we set a current time. And blah, blah, blah. Okay, so this is every time we create a new thing. Wait, why infinite plus 10? Oh, infinite is this. Just to get slightly bigger, right? So VFS from this And this thing doesn't change. This is the state. But as you're going through, I call A. Okay, I see that. So I BFS this. Interesting. And eventually I check. Because bisect left, I can pass a key. Wait, what? Bisect left, range, and key. What is true? What? I never see this used. Bisect, right, Python. Okay, we have AX, low, high, and then key. What is this usage? This is A. If this is X? Wait, what? Wait, what? Wait, what are we bisecting? We have this range, right? And we want to find anything that's, wait, hold on. The key is the comparison. Okay? I think the key specifies extract a comparison key from each element. Wait, hold on. The default way is to hold on. The X, so if we don't pass anything, we're trying to find to maintain sorted order. Parameters low and high may be used to specify a subset. Yeah, this is fine. Yeah, this is also fine. For one argument that is used to extract a comparison key from each element in the array to support searching complex records, the key function is not applied to the X value. Oh, it's in 3.10. It did not exist in the past. Lordy monstrosity. Holy guacamole. How do you use this key function? Wait, hold on. Are they even running Python 3.10? But okay, hold on. So okay, let me first summarize. The method is the same, right? But he does quite a few things I think is smart. The first thing is because the file and the person are both doing BFS, so we can roll the same BFS for them, and they both cannot reach a it's the same thing, right? They do the same thing. The only difference is, but there is a difference. The only difference is when you do the file BFS, you will actually put the time tick into the original matrix. But when you do the actual thing, you don't update the original value. You just put a scene, right? You put a scene, you do this, the scene gets upgraded, which is obviously fine. And then at the end, you have this key function, which I still don't understand what it does. I know it's a comparison key for each element to support search in complex records. Key function. What do you mean it's not applied to the x value? If it's not applied to the x value, what does this key function return? Hold on, let me think again. We want a binary search, right? And we just basically say a binary search based on the key. Because each time when we search, we determine, right? What's the key function like the regular binary search bisect? Well, the key function will be we find the middle and we compare the middle to this value, right? Compare the middle to this value. That's the original, the regular key function. But here we don't do that. I think I understand now. I think I understand. If the element are compared directly with no intervening function calls. So when you use key function, do I even have Python? What is my Python version? 3.9. It's not even 3.10. Lordy, I can't even test it. Yep. We have all the way to 3.10. I want to play with it. So pyinf install 3.10. I think it's 0.10, right? 3.10.10. So 0.10.0. Mighty almighty. This is crazy. Oh, I didn't realize. Huh. So this means you can use bisect to do any binary search. Anything, right? Which means you have the range specified, okay? And then you put, so you want to say, how do we compare? Basically, how do we compare the mid value? The mid value. Okay, so now we want to find the maximum time, right? The maximum time. How do we find the maximum time among this? So if it fits, we want to go higher. If it fits, we want to go, like if this one fits, we want to go higher. But if it doesn't fit, we want to go lower. But why is it why is it bisect left? So bisect left we find, yes, bisect left, because we have a bunch of similar values. We go to the, but yeah, we go on the left side, right? The left. I mean, honestly, it doesn't matter. What we say is, if something matches, we always, if it, yeah, this one shall return true or false, right? This one return true or false. This one return true or false. Which is if seen is larger than this. What does that mean? That means it doesn't find? Ooh, hold on. A minus 1 is the time to reach there, right? The file will take to reach there. So if you get there before, then you're good. So if c minus 1 is smaller than, smaller or equal to, is that smaller or equal to? Yes, if it's smaller or equal to the a minus 1, that means we can reach there, which means we need to push the lower bound. We can get higher, right? We can get higher. So what is this, true or false? What is this, true or false? The comparison. If you think about it, in binary search, if it's true, right? Hold on. Oh my god, if this is true, if the mid value is larger than, right? If it's true, wonderful. If it's true, we want to find where to put this. If the mid value is larger than this, so we need to put high and low, yes, which means if the key returns true, the high will bring back to middle, right? If it returns false, then we bring low higher. So in our problem, if it finds, right? If it finds the good thing, right? If it can reach, we need to bring mid up, which means we need to return false. If it fails, we need to return true. That's exactly what this is. If it fails, we return true. If it finds, we return false. So that way, bisect left can give you, what is the, so we will get down to final thing, right? The final thing. Okay, so now the question is, we'll get down to the final thing. What is the exit condition for bisect left? We have to read the source code of bisect left. Okay, so bisect left is, if we find the same value, we will keep going left, right? So same value will keep going left. So same value will keep going left until we find, which means if we find the same value, we will always return true. So return true will bring the high lower. Right? Return true will bring the high lower, which means in this case, if we and the goal is to keep pushing lower, right? Lower is the key. So which means if we don't find it, we keep lower, keep lower. If we find it, we go higher, right? But we always bias towards going lower. Right? Always bias towards going lower. Oh, does that make any sense? No, that doesn't make any sense. Do we have a source code for this? We had a key goes by year. How do I get to the... Oh, I guess this is how you get there. Oh, we're in C Python now. Bisect right. Here we go. Return value is such that all E have... Yeah, we know that. If high is none, okay. If key is none. Yep, this is the thing. This is the thing. Binary search. Right? If x is smaller than a mid, x is the target. If it's smaller, so the middle is too high, then we bring the high to the mid. Otherwise, the low will go up. And by this search, because we require x must be smaller to this in order to bring the high low, right? So that's a more stringent requirement, which means if it's equal, we'll bring the low up. If it's equal, we'll bring the low up. So eventually, we will push to the right side of the equal value. That makes perfect sense. Now, if we use a key, a mid, so key is a function, and a mid. So we say if x, hold on, x is smaller than a mid. Wait, x is smaller than a mid. So if we want to use this in replacement of binary search, this one must return whatever the key. Is that what it says? Hold on. Okay, we got this. Yeah, we never created one. Let's just call Python virtual win. We call it LeetCode 3.10.0. Oh, I think I got the command wrong. This one, LeetCode. Yeah, we create a virtual environment here just to play around. Okay, we're gonna go Python local LeetCode. All right, so pt upgraded, and then as always we install pt python. So this is specific to 3.10. Then we go in here. Okay, say from bisect import bisect. Let's go right. Yup, it has a key. You see that? It has a key. But okay, this is not what we want. What we want is true smaller equal to false. Is false. True smaller than true. True. Okay. But bisect left is, hold on, so false smaller than true. True smaller than true. So by putting x is true, because he used bisect left, so put x to true, and the key value, whatever the key value gives you, will reverse. Oh wait, this is not what I expect. This is not what I expect. Hold on. Wow, didn't expect to learn all this. Let's go back here. So let me first think again. What does bisect right means? It means if the current value is smaller, then we bring the high to low. But if the current value is bigger or equal to, right? If it's equal to, we bring a high. That's good. Perfect. And the key is simply we use key to create another value to make the comparison. And then we do the same thing. Okay, that's fine. Bisect left. So we want to push left. So how do we push left? We say if this value is smaller than what you have, right? Which means the x is larger than, right? The x is larger than the middle. If I'm larger, which means the middle is too small, then we need to bring low high, right? But we want to push to the left, so bring the low high needs to be more stringent. So it has to be x larger than, right? If x is equal to, we bring a high low, right? Bring a high low. So we always bring the high to the mid. You see that? We always bring the high to the mid, and then low go up, and eventually we will meet a position, right? We'll hit a position that is the right position to insert. Okay, so in this case, if key return a value, whatever value, and then we find out that if it's false, this will evaluate the true, then we will bring, hold on, so which means if this is true, okay, if this is true, this one evaluated to false, then we will go high, which means if the key function is true, we'll bring a high lower. What does it mean our problem bring a high lower? Which means we can wait for shorter time, which means we cannot reach the destination. So if we cannot reach the destination, if we cannot reach the destination, we must return true. If we can reach the destination, we return false, right? Because if we cannot reach this one, return true, this one evaluated false, then we bring a high to low. If we can reach, they will return false, which will evaluate as true, so we bring low up. So this is just a binary search. And I think if we do, say false is smaller than false, that evaluated false, and false is smaller than true, that evaluated true. So we can use this, but if we use this, x must be false, right? And then if it is false, it'll be false. If it's true, and it'll be true. But we don't want to use bisect right. Why is that? Because no, I think it's the same. We always go low, mid, plus one, right? No matter what. So in this case, I'm gonna try it out. And of course, I'm a global switch, so when I run it here, it will switch to that as well. Alright, so I'm gonna full out trying his method. Oh man, how much time have we done? 48. Okay, so let's do this. Okay, so what do we do? We need to find all the fires. Okay, so we have fires equals to for I m n equals blend grid grid 0. Okay, so for I in range m, for j in range, and I think I forgot to say range. The heck? I typed. Oh, it's not on the same line. My bad. Okay, so this is range. Okay, and then we say if, right? So if grid I j is equal to 1, then not the best thing to do. Yep. Then we're gonna say ij0. Yeah, so that's the file. And then we need to turn everything into I in range m, j in range n, if grid ij is not equal to 0, then grid ij equal to 0. Else, yeah, I thought about them equal to minus infinity, right? So this is set the stage. All the file initially is going to be this. Okay. So that's the grid. Now we're going to write the BFS code, right? BFS code. Yes, do the BFS code. So say def BFS. What do we need? We need a queue, right? We need a queue. And what? What else do we need? We need a queue, and we need a scene. We will call it visited. All right, visited. So that's what we need. And then we're just gonna go through, say while queue, right? And then we say temp is equal to this. For ijt, oh, we need to pass. Do we need to pass t to this? I don't think so. In queue, okay. Now we visit it. I like how he does it. When we visit it, then we say visited ij equals t. So at a t time, I visited this, right? And then we say for ninj in. We've done this already many times. didj, my bad. So actually, we can copy both. Right, and we say if 0 smaller equal to ni smaller than m, and 0 smaller equal to nj smaller than n, and if we want to go there, then we say grid, right? We say grid ni nj has to be smaller, right? It has to be smaller. No, it has to be the t plus 1 must be smaller than this. Right? T plus 1 must be smaller than this. That means I can reach you. Otherwise, it doesn't work. So if these satisfy, then we say temp append ni nj and t plus 1. That's the next time tick, right? Next time tick. So it has to be smaller than the grid, right? And it also has to be smaller than visited, right? Yeah, because we cannot revisit something that has been already visited. So we also need to be and then the t plus 1 next time, which should be smaller than visited in ni nj, right? Is this what it is? I feel like this is not how it was set up in the actual solution. In my mind, right? We have to do the fire. We have all the fire numbers in there. And we basically just say it has a smaller than this, which means it has to be smaller than a fire, than a wall. This is the wall in a fire. And it has a smaller than visited, which is what we have visited already. So then we say t, and then blah blah blah, finish them all, finish everything, and then we say q equals to temp. Right? Temp, keep going, so that's BFS. All right, so now what? Now we're gonna do fire first, right? So in the BFS, fires, that's the queue, and visited is the grid directly. Once we're done, we say grid -1 plus equal 1. So this is edge case for the safe house. Make it delay its burning. Delay its burning. So if we delay its burning, if they reach the same time, I still win. Okay, so now that's done, we are going to do, what are we going to do? I'm gonna say def key, not the best name, so def this is going to be path can reach safe house, right? We will pass a time, a visited, right? And then we simply just do BFS. We can initialize Q. We say BFS. What is Q? Q is just 0, 0, t. Right? I have to wait it for that much time. Then we start. Right? Then we start. So this is that and visited. And once we're done, we're going to return visited -1, right? So we want to not reach to return true. What does it mean by not reach? Not reach means visited this, not reach. Reach means this one is smaller equal to, so not reach means this one's larger than grid -1. Right, this is not reach. We return true. If we reach visit is smaller equal to, then we return false. Okay. So with this in mind, let's say from bisect import bisect left. Okay. So with this, we're gonna do bisect left. Maybe we can just do list range or just range. 10 to the 9th plus 1. Yeah, we have every minute, and then we're going to do true, because if it's true, then this is when it's true, right? If it's false, this is challenging. So okay, so bisect in bisect left, right? In bisect left, key smaller than x. Right, key smaller than x is larger result in, oh my god. So the things to compare, like if this one is, if you think about the mid if it's too small, then low need to go up, right? Is that right? Oh man, bisect left. If key is smaller, yes, low go up. Low equals mid plus 1. If this evaluates to true, elsewise high equals mid. Okay? So in our case, we want reach in safe house, right? Lead to, if I reach safe house, that means I can push house. Must make key x evaluates, make this evaluates to reaching safe house, must make this evaluates to true. Okay, so if we set x equals true, that's not right. I said reach in safe house. All right, we have a problem. We have a problem. And I can just use range. It says scene is larger than the grid. Oh, this one, I actually cannot do it here. We'll do it inside. Oh, this is going to be math.inf times n for this in range m. Right? So visit to the larger there. Yep, a little bit confused now. If key in this is smaller, because that's the code. That's what we see here. Bisect left. If this is smaller than, right? If key is smaller than, then low. If this evaluates to true, okay? So if the mid, if this evaluates to true, then low So reach and save house, this thing need to return Oh, yeah, it's right. Hold on. So reaching safe house makes this evaluate to true, which means reaching safe house leads to key evaluates to false. Hold on, no. If we set x to true, then reaching safe house leads to key evaluates to false, right? So if reaching safe house leads to this one evaluates to false. So let's call it reach safe house, right? So if visited, if I can reach, so this is if reaching safe house, if can reach safe house, return false. If cannot reach safe house, return true. Because if I can reach safe house, visited will be smaller than grid, right? So this one will return smaller equal to false. Yeah, that makes sense. So by saying this is true, and then key equal to reach safe house. And this one will, because it's bisect left, it doesn't really matter. It's just because we don't have the same value. So we just need to find a value, right? We need to find a value that just fits. Now that I'm thinking about this, we can only do, can we do like the minimum, the maximum, right? We can find a maximum. Basically, if we want to find a maximum is if we just push higher, right? We push higher until we cannot push anymore. And because we push higher, so if it's good, we push higher, right? It's bad, we say it the way it is. It's good, we push higher. So whenever we fail, we go down. So that's the maximum we can do. So we say -1. And then we return this. Let's see if it works. We probably need to we have to change the build. How do I go to the build? Shoot. I want to see where it is. User. Package library, sublime package. Okay. We're going to have to go there. Alright, it's been a while today, so I'm going to just cut it right now. There's a lot of things I want to try and I want to do. But I will hold on to it. So this is a very interesting learning experience. I think I probably will write an article about this. Yeah. Alright, I'll see you guys tomorrow. Adios.